Okay, this is the Helicopter Flying Handbook, Chapter 12, Attitude, Instrument Flying, Introduction, and Flight Instruments. All right, so introduction. Attitude instrument flying is the control of a helicopter by reference to the instruments rather than by outside visual cues. The pilot substitutes the various reference points on the helicopter in the natural horizon with the flight instruments. Control changes required to produce a given attitude by reference to instruments are identical to those used in helicopter visual flight rules, VFR. This chapter introduces basic instrument training. It is a building block towards attaining an instrument rating, but is not a substitute for the more detailed information found in the Instrument Flying Handbook and the Advanced Avionics Handbook. This chapter is designed to enable the pilot to maintain control of the helicopter during a 180-degree turn in the case of an inadvertent encounter with instrument meteorological conditions, IMC, if equipped for IMC conditions. If not, the pilot should strictly maintain visual meteorological conditions, VMC, rather than penetrating clouds or fog and land as necessary. Flight instruments, page 2 of 6. Operational flight instruments free the pilot from the necessity of maintaining visual contact with the ground. When attitude instrument flying, it is crucial for the pilot to understand how a particular instrument or system functions, including its indications and limitations. It is also important for the pilot to ensure the helicopter's instruments are operating properly prior to a flight. A helicopter pilot can easily make a preliminary check of flight instruments at a hover prior to departing on a flight. For example, as collective is increased, the altimeter indicates a decrease in altitude by about 20 feet for most helicopters. This decrease is due to the increase in air pressure between the main rotor and the ground effect. As the helicopter rises to hover, the altimeter usually recovers to indicate field elevation. During the hover, heading indicators can be checked for freedom of movement, and correct indications and the freedom of the slip indicator can be verified. The proper operation of the attitude indicator can be checked during the hover by gently pitching the nose of the helicopter up and down and rolling from side to side. Instrument check. The pitot static system and associated instruments, air speed indicator, altimeter, and vertical speed indicator are usually very reliable. Errors are generally caused when the pitot or static openings are blocked. This may be caused by dirt, ice formation, or insects. Check the pitot and static openings for obstructions during the pre-flight. Turn indicators and magnetic compass are also important components of attitude instrument flying. Instrument checks ensure reliability of these instruments. Airspeed indicator. During the pre-flight, ensure the pitot tube, drain hole, and static ports are unobstructed. Before liftoff, make sure the airspeed indicator is reading 0. If there is a strong wind blowing directly at the helicopter, the airspeed indicator may read higher than 0, depending on the wind speed and direction. As takeoff begins, make sure the airspeed indicator is increasing at the appropriate rate. Keep in mind, however, that the airspeed indicator might be unreliable below a certain airspeed due to rotor downwash. Altimeter. Before liftoff, set the altimeter to current setting. If the altimeter indicates within 75 feet of the actual elevation, the altimeter is generally considered acceptable for instrument use. Turn indicator. The needle portion of the turn and slip indicator shows direction of turn and rate, figure 12-1. For instance, if the needle is centered on the standard rate turn marking, the helicopter will complete a 360-degree turn in 2 minutes, figure 12-2. Another part of the turn and slip indicator is the inclinometer. The position of the ball defines whether the turn is coordinated or not. The helicopter is not in a coordinated turn anytime the ball is not centered, and usually requires an input to the anti-torque pedals and angle of bank to correct. All right. Figure 12-2. In a coordinated turn instrument, the ball is centered. In a skid instrument 2, the rate of turn is too great for the angle of bank, and the ball moves to the outside of the turn. The pilot must decrease right pedal and add left pedal to center the ball. Conversely, in a slip instrument 3, the rate of turn is too small for the angle of bank, and the ball moves to the inside of the turn. The pilot must add left pedal to center the ball. During pre-flight, check to see that the inclinometer is full of fluid and has no air bubbles. The ball should also be resting at its lowest point. Since almost all gyroscopic instruments installed in a helicopter are electronically driven, check to see that the power indicators are displaying off indicators. Turn the master switch on and listen to the gyro spool up. There should be no abnormal sound such as a grinding sound, and the power out indicator flag should not be displayed. After engine start and before liftoff, set the direction indicator to the magnetic compass. During hover turns, check the heading indicator for proper operation and ensure that it has not precessed significantly. The turn indicator should also indicate a turn in the correct direction. Magnetic compass, page 3 of 6. The magnetic compass is one of the basic instruments required by Title 14 of the Code of Federal Regulations, 14 CFR, Part 91 for both VFR and Instrument Flight Rules, IFR. The compass can be one of two types: wet, the compass is suspended in fluid, or vertical. Prior to flight, ensure a wet compass is full of fluid. During hover turns, the compass should swing freely and indicate known headings. Because a magnetic directional indicator is required for all flight, any malfunctions must be corrected prior to flight. Helicopter controls and performance. Helicopter control is accomplished by controlling the aircraft's attitude and power output. Attitude is the relationship of its longitudinal and lateral axes to the Earth horizon. When flying in instrument flight conditions, the pilot controls the attitude of the helicopter by referencing the flight instruments and manipulating the power output of the engine to achieve the desired performance. This method can be used to achieve a specific performance level, enabling a pilot to perform any basic instrument maneuver. The instrumentation can be broken up into 3 different categories: control, performance, and navigation. See FAA H-8083-15 Instrument Flying Handbook for a detailed discussion of these 3 categories. Although this chapter discusses helicopter instrument flying, the concepts in general are similar to airplane attitude instrument flying. We'll hold off there, page 3 of 6. That is your flight instruments. All right, now we'll go into helicopter control in the bottom of page 3, but going into page 4. We'll leave it right there. All right, see you. That was page 3 of 6.